Welcome to Math Mini Lessons. My name is Sarah, and in this video we're going to be reviewing the 5th grade 2023 State Math Test, specifically the multiple choice questions. We have another video you can watch if you want to see how we answer the open response questions using the equation editor online. So I answer them on paper, and I even show how to put your answers on the computer for the new platform. But here we go. Before we jump in, some quick things to know. You can find a copy of this test online in the description. I'll leave a link where you can either download and print or download it on an iPad or a tablet, and you can work through the problems. Now, there are 35 multiple choice questions, but they only give us 19. See, release questions, only 19, which means that 16 are going to be missing. So if you see numbers go 1, 2, 5, 6, that's okay. It just means that they took out 3 and 4. That's all it's going to mean. What I suggest is you print out the test, take it for yourself, mark down any of the questions that were really easy or questions that you want to go back over, maybe with a star, or if you guessed, put a little question mark, because then you can see those questions when I review them over here. So stop, hit pause, go try to test yourself, and then come back to this video. I'm going to give you all the answers and then show you how I solved. There'll be timestamps in the video, so if you got the answers right, you can go to the next page. So with that, we're going to jump right into 5th grade. Super excited because I've taught 5th grade, I think 5 times. So I love doing 5th grade math. Let's jump in, Math Marvels. All right, here are the first 3 answers, C, A, and B. So check your work and see if you have the same answers. If you do, just skip over to the next section of the video. If not, stay right here and I'll show you how different ways of just solving a problem. This is your first time on Math Mini Lessons. You're going to see me do it in lots of different ways. I try to go from easy to more complicated and let you know which strategies might be easier but take a lot of time, or which ones are a little bit spicier. So I'll share that with you. So we'll start with the first one. There is 7/8 of a whole pizza in the refrigerator. He eats 3/8 of the whole pizza for lunch. What fraction of the whole pizza is left? So 2 ways I can see kids doing this. One is to just draw the pizza, or just draw a model with 8 pieces. And we know that there was 7/8. So I'm just gonna, here's what he had. And then he ate 3 of them. So he ate 3. And so how much was left? And this is a real easy model to show that he had 4/8 of the pizza left. So that's one way if you want to get really, really concrete. Or I know there's some kids who might just draw, here's 7 pieces, 1, 2, 3, 4, 5, 6, 7, and literally say each of these are 1/8. It's just another way. And you can see these take more time because I have to draw them, and then just show he eats 3 of them. So 1, 2, 3, and then you can just count up what you have left, which is 4/8. So easy to understand, take some time. Another way is you could just recognize this is a subtraction problem, because as you eat pizza, you're getting a smaller amount. And so you can represent your number sentence and just get 4/8. They didn't ask you to simplify it, so this would be the final answer for now. If you simplified it to 1/2 and didn't see your answer, you could always check to see did you have another equivalent fraction that was bigger. Let's look at the next one, and we want to represent the number 99 thousandths. So I think of numbers as first name, last name, and these are in the thousandths place. So I look at the family of the thousandths, which are my decimals. And in this family of decimals, I have my tenths, my hundredths, and here are my thousandths. And I need to have 99. My decimal is going to be right here. And I need to somehow, with these 3 numbers, there are going to be 3 digits in here. I have to have 99. So here's the first thing. If I just put 99 here, this would be 99 would be the first name, hundredths. So that's not what we're looking for. So if I tried this and said this is 99, we'd be missing a place value here. So this is 909 thousandths. So thinking about that. So my 99 has to be, I would start it back in the thousandths place and move up. And so I have 99, and then I would add my placeholder. So this is 99 thousandths. Another way you could actually solve this is by turning all of these numbers inside into a fraction. So looking here, I have 0.99 over 1,000. Here I have 990 over 1,000, and I know that's not what I wanted. And it's easier to say, right? Because I could just read the numerator and then the denominator, like a first name and a last name. So 999 thousandths would be wrong. The next one would be 9 and 900 thousandths. So again, I'm just reading it like a name. That's wrong. And the last one, I would have 99 whole numbers and nothing, so just 99. So those are two ways that you can use. I'd say its name, so 99 thousandths. I can just know my denominator is the thousandths, and I just have to put a 99 up top. So that's just another way of just recognizing it and then trying to draw it up. All right, so jot that one down. Let's go to the next one. We have a shipping box with, it's a prism, so this tells me volume, a right rectangular prism with a base area of 16. So the bottom I know is 16, and I know it is 6 feet high. All right, so I'm gonna have some type of box, 6 feet high, and they're not telling me what my length and width are, but I know that when they're multiplied together, I get 16. So volume is equal to base times height. I'm going to use that one because I have the base area. And now I can just put in my numbers. 16 times 6. Notice I use parentheses. And when you multiply them, you get 96. All right, so hit pause and you can jot these down into your notes. Make any changes you need to. And if you have questions, put them in the comments. Let me know if you had a question or a different strategy to share. All right, notice we skipped all the way from 3 to 8 because they took those questions out. That's okay. This is one of the multiple choice questions we have, and the answer is D. So check your work. If you got it, awesome. Move on to the next section. And if you want to see how we solved it, or this one was a challenge or a guess, stay right here. There are 3 different ways that I thought of for getting this answer. The first way was to think, what if I just expanded this 10 to the 4th power? Like, let's face it, this is the part that's hard. We know how to multiply 32 times 10. But what does 10 to the 4th power mean? You could just expand this out and know that 10 times 10, that's 100, times 10 is 1,000, times 10 again is 10,000. And now you have your answer, 320,000. So that's one way, which is to just expand my exponent, 10 to the 4th. Another way we can do is shift the decimal. And I see this more, honestly, in middle school, where I know I'm going to have 32. And when I think of 10 to the 4th power, my numbers are getting bigger. Every time I multiply a number by 10, I move my decimal point, and there's an invisible one right here. It's moving to the right to go bigger. So this is 10 times bigger, or 10 to the 1st, 100 times bigger, 1,000 times bigger, 10,000 times bigger. So notice I made 4 shifts. 10 to the 4th means I made those 4 shifts, because again, 10 times 10 times 10 times 10. So I made it 10 times bigger 4 different times. And now that my decimal point is back here, I just had to remember where my comma is, and you would just think of your families. There's 3 numbers here, so I have to put a comma there. So I would just rewrite it as 320,000. So that's the second way that you can do this. Harder, and I see this more in middle school, to be honest. So it's okay if you still need the first way. The third way I sometimes see kids write this number is I see them putting, here's 10 to the 1st, 10 to the 1st, 10 to the 2nd, 10 to the 3rd, and here's 10 to the 4th, and they would put their 32 here and put 1, 2, 3, 4 circles. So this is a way that can work as well. The only challenge here is that some kids are like, can I have 2 numbers in one place? Well, no, we would usually move my 3 to the next place. So I still have 32. So it's the same as 32 in this place. You can also just split it this way. So this one's a little bit more challenging. I don't see a lot of kids do that. Honestly, the one I see most kids do is the first one. That's the one I see the most. But all of them will give you the same answer, 320,000. And notice how I'm reading it. I say the first name, 320, and it's in the thousands place. And I don't say anything about these. All right, hit pause and jot this one down into your notes. Number 9, which model is shaded to represent the area of a rectangle that is 4/5 centimeters long and 3/10 centimeters wide? So this is an area, so I need an area model, which means it's going to look like some type of rectangle. And I'm just thinking of the 2 degrees. Now, the answer for this one is B, clearly, but I'm going to show you how I would figure this out. Looking at the ones, pretty much what you're doing is you're figuring out what fraction it represents the length and width. So with this one over here, I have 1, 2, 3, 4, 5. So I have 5 out of 5 shaded. So I would write that. And on the next part, I only have 3 out of 10 shaded. So that's not what I wanted. I wanted 4 out of 5 times 3 out of 10. So that doesn't work. With the next one, same one, I just went from left to right. So here I have 4/5 times, as I'm looking down at the bottom, I have 10 over 10 shaded. So unfortunately, again, those aren't the numbers I wanted. B works because here I have 3 out of 10 times 4 out of 5. I can clearly see it. That's why B works. And D doesn't work at all because it's not an array. Like here you have 3, but I can't say this is 3/10 because this entire part over here isn't shaded. So it's not a complete rectangle. If this is not a rectangle, then this is not something, I can't model this with 3 out of 10 times 4/5. That's not what's represented here. Okay, so we'll skip over that one and we're going to hit pause so you can go on to the next one. And I hope you're seeing in this video how I can go in and just really use models to show the mathematics. Like, I love that we can make visuals with this. And if you like this video, like and subscribe. If you've been here before, thanks for coming back. Let's go to the next one. Here are the answers for 10 and 11, B and C. So check with your work. If you got them, keep moving to the next section. If not, stay here. The first one is just a simple division problem because I have 2,232 spaces and they are set up in rows of 24, even rows of 24. So all my rows add up to the parking spaces. I have 2,232 divided by 24. Now, 2 things I'm going to put for you because division can be really hard for kids. I'm going to leave the steps here on the side. Divide, multiply, subtract, bring it down. And my kids remember this by saying dead monkeys smell bad. And that's how they remembered the steps. Or they will say it as a cheer. Divide, multiply, subtract, bring it down. Hey! And they will set up their division. And guess what, Math Marbles? I don't know my 24 times tables. I don't need to know my 24 times tables by heart. But what I can do so that I don't have to figure it out in the moment is I can start skip counting by 24s so that I can do the hard part here. So see, I counted by 5s, 24, 48, 72. Then I had to do a little bit of mental adding. And so that's times 5. 24 times 10 is 240. And now in my head, literally, I'm just adding 120 to all of these. So the hardest part I'm doing now is just addition instead of dividing. So I have 144, 168, 192, and then 216. So the hardest, I made the hard part adding instead of dividing. Now, I have 4 numbers inside here, 4 digits, 1, 2, 3, 4. So I want to make sure I have a place for 4 digits up here, even if the digit is a 0. This way I'm not going to make a mistake in my place value. And now I'm going to do my steps. I'm going to try and divide. I can't do 2 divided by 24. So I'm just going to put a 0 up top and go to my next digit, which is 22. I don't have enough to do 22 divided by 24. So I'm going to put another 0 there. Now I'm doing 223 by 24. So how many groups of 24 can I take out of 223? I can take 9 groups of 24 because that's 216. So 9. Now I don't have to multiply. I already know that's 216. So I'm divided, multiply, subtract 7, and bring down to 2. And now I can do the last step, 72 divided by 24, which is 1, 2, 3. There we go. And 3 times 24 is 72 and a 0. So what I love about this is look at how the work looks exactly the same. You can't tell that I didn't do the math in my head. But instead, and I didn't have to guess and keep trying to guess what that number would be. By doing my skip counting, I made the rest of my work easier. I did the challenge early, and it wasn't even that challenging. All I was doing was adding 24, and that way I can do my division. This is a great strategy for kids, and no one can tell you that you're doing it wrong. So keep that in mind. Here's the next one. Not so spicy. A teacher has 20 feet of string, and she uses all the string in equal amounts of 8. So this is also a division problem. 20 divided by 8. How do I know? Because 20 is the total, and she puts it into 8 equal amounts of 8. So that's how I know. And you can read the problem from top to bottom. 20 divided by 8. So we have that part in here. Okay, so what is that going to be? Here are some different ways you could solve this. You could just do 20 divided by 8 and go, well, 8 can go into 22 times because that would just be 16. And then you'd end up with 4 8s left. And then you would simplify it to 1/2. That's one way. I can see kids making 20. So far I have 4 groups of 4 at 16, 17, 18, 19, 20. And then thinking how many groups of 8 do I have? So I have 1 group of 8, 2 groups of 8, and I have 4 left out of another group of 8. This one's incomplete. And then they would also simplify it. So those are 2 quick ways that you can do this, or if you wanted to do it as a long division, you could do this as well. So the spicy part really isn't the dividing. I think most kids get that it's 2 and you have a remainder of 4. The challenge is you have to simplify this fraction, the 4 eighths. And ways you can simplify fractions. I'm trying to think of easy ways. You can just think, what are common ways that I can divide both numbers? So if it doesn't stand out to you as 1/2, you could just use the factors for both. So for 4 is 1, 2, and 8. And for 8 is 1, 2, 4, and 8. And you can look for the greatest common, oops, made a little mistake here, 1, 2, and 4. That's what I meant to say. And then you can look to see my greatest common factor is 4, and so then you would just divide by 4 over 4 to get 1/2. So that is how, if you're stuck on how to simplify, you can just use your greatest common factor. Just be careful that you don't make a silly mistake like I just did. Slow yourself down and list those factors. All right, so we're gonna pause here so you can jot this down in your notes, and we're gonna go to the next section. The answer for number 14 is C, 6. Let's see how to solve it. There are two steps happening here. We want to know what digit is in the tens place after we divide this number by 10. So I have 8,642 and I am dividing it by 10. So some kids are just going to say, well, I just take my number and I just move my decimal one place to divide by 10. So you can do that and now just say, oh, there we go. My 6 is in this place. That's one way to do it. If you get really stuck, then you could also just divide by 10 if you really needed to do this part. That's okay. Sometimes we are where we are. 10 goes into 86 8 times. 6, bring down to 4. 10 goes into 64 6 times. Bring down to 2. 10 goes into 42 4 times. And you do have a remainder, so I don't want to have a remainder here, but I'm going to add a decimal. Pop one up there, and now I can keep on dividing. 10 goes into 22 times. And then you can see, well, this has to be my tens digit. So either of those ways work. If you still get stuck figuring it out and you move the decimal, you can literally just go and start thinking about your place values by writing ones, tens, hundreds. All right, hit pause and jot this one down into your notes. Here are our answers for 17 and 18, B and D. 17 is a little bit spicier than 18, just fair warning. So if you have it, keep moving. If not, stay with us. With the first one, 17, we want to know which has a value less than 1.5. So two ways you can approach this. You could just go and solve all of these to figure out which one has an answer of more than 1.5. So 3 halves times 3 halves. All I did was change my 1/2 is 9/4. And I know that 9 divided by 4 is 2. I already know that this can't be the answer. I would get 2 1/4. And I want something that's less than 1.5. So this is one way. This one gives me 3/4. That is definitely less than 1. So it's less than 1.5. So you could just do this and just solve them all out. The other way is all of these numbers are being multiplied by 1.5. So you can do some thinking. And if I multiply 1.5 times 1, I know I'm going to get exactly 1.5. If I multiply it by a number that's bigger than 1, like any number that's bigger than 1, then I'm going to get a number that's more than 1.5. And if I have 1.5 and I multiply it by a number that is less than, I'm putting a -1, I know that looks weird, that's less than 1.5, then that's going to give me a product that is less than 1.5. So that's a thinking part that you can think about. So if I want to equal, I have to get a number times itself. It'll give me the same number. If I want the number to be more than my product to get bigger, then I have to multiply it by a number that's bigger than 1. If I want my product to be smaller, I have to multiply it by a number that's smaller than 1. And looking here, so I'm looking for a number smaller than 1, and right here I'm multiplying by 1/2 that is smaller than 1. So that's just a convention. So again, you have two different methods. Pick the one that makes the most sense to you. The convention, that rule of more than 1, less than 1, can be a little tricky for some kids. The second one's not so spicy. It's a volume problem. We want the total volume of prisms A and B. So meaning I'm going to find the volume for A and I'm going to add the volume for B, and that's going to give me the total. The volume for A is super easy because it's just a base. So I don't really have much of a height. I can literally see my dimensions here. 3 times 3 times 1. And that's just going to equal 9. So volume for A is 9 cubic units. The volume for B is 3 times 3, and then my height is 3. So I'm looking in 3 places. 3 times 3 times 3. So I'm doing the same thing, or some kids go this way. 3 times 3 times 3. You could do that. 1 times 3 times 3. So you can use that corner to really help you see all your numbers. So my volume for the second one, B, is equal to 3 times 3 times 3, which is 27. And now you just add them together and you'll get 36. All right, so hit pause and jot that down. And again, if it helps, you can use that corner to find those dimensions, because you can literally see all 3 of them right here. All right, let's look at 20 and 21. You can see they skipped 19. The answers are A and B. So we'll start with number 20, where we're measuring rainfall. And we know from Friday, Saturday, Sunday, it was 34 inches. And we know that Friday was 11 and 25 Sunday was 9 and 1/10. So here are just things we know in the problem. We're adding up all the snow from, we want to put Friday plus Saturday plus Sunday is equal to 34. And we know 2 of the numbers, 2 of the values. But we have no idea what Sunday was. I'll just leave that as an S, is equal to 34. So things you can do here. I have seen some kids do this with a number line, whatever it is, but pretty much everyone starts by adding up these 2 numbers. They always start with that and just combine it. It simplifies it. So let's do that. I like to stack. And I like to stack because I can stack up my decimals in a row and then put the numbers down, and I don't mess up with a placeholder. Now I can just put a placeholder here and I can add. 2 plus 9 is 11. 2 plus 9 is 11. And I get 21 and 1500 plus whatever Sunday was is equal to 34. All right, so now you have 2 choices and you're just gonna subtract. And I just want to show you the 2 different ways you can subtract, because I get a ton of kids who get this wrong. First, I'm going to put a decimal behind the 34 so we can stack this up and put 2 placeholders. This is a double regrouping problem. A lot of kids have a hard time here because they have to borrow twice with zeros. That doesn't make a lot of sense. So what you could do is called a trade first method, meaning I'm going to trade from the left first and just ask, do I have enough? 3 minus 2, do I have enough? Yes. 4 minus 1, do I have enough? Yes. 1 minus 0 minus 1, do I have enough? No. So that means I'm going to borrow from the very beginning and regroup, and now I have 10. 10 minus 1, do I have enough? Yep. 0 minus 5, I do not have enough. So I'm going to borrow again. And now I have enough. And now you can subtract real easy because you did all the hard work first. You did it in the beginning. So 10 minus 5 is 5. 9 minus 1 is 8. 3 minus 1 is 2. And 3 minus 2 is 1. 1285. So that's one awesome way that you will never get it wrong, literally by asking the question, do I have enough? And going left to right. Another way that you can solve this, I call it take a penny, leave a penny. So watch what this looks like. So I have 34 minus 21.15. What if I just took a penny out of here? So I had 33.99. I'm thinking of it like pennies, but literally I'm just taking the smallest one out. So I took out 100th. Now I can subtract and have no borrowing. 9 minus 5 is 4. 9 minus 1 is 8. 3 minus 1 is 2. And 3 minus 2 is 1. So I take a penny. So that's all I did. I took away 100th. And now I just need to add it back. I borrowed it. I brought it back. All right, there you go. Both ways give you the same answer. You can either trade first, left to right, or you can use take a penny, leave a penny when you see a problem like this, where you have 2 back-to-back zeros and subtract. Both will give you the right answer. All right, so jot that down, share it with friends. They always think it's a trick and it's not. All right, let's do the next one. Dorian walks an average speed of 2.5 miles per hour, but he doesn't walk a whole hour. He only works 3/4 of an hour. How much did he walk? So I really want to know, what is 3/4 of 2.5? That I can represent with multiplication. All right, I'm gonna regroup this number. I'm gonna rewrite it in another way. So 2.5 is the same as 5/2, and that gives me 15/8. So a little spicy because there's a few steps I have to do, but that's okay. 15 divided by 8 is 1. That's some mental math. So 1, and I end up with 7 as my remainder, 7/8, which is my answer. Okay, so the key to this one was just being able to recognize that this is what they're asking, and I can represent this with multiplication. And then I'm just using my fraction skills to multiply and then change it, mixed numbers and improper numbers, and I just have to be fluent to change them back and forth. All right, hit pause and jot this one down in your notes. The answer for 26 is D, 1498. It is a multiplication problem, so I'm going to give you 3 different strategies for multiplying if you find this really hard. If you already have this down, you can keep moving. If you found you make a calculation error, just see if you can identify where and try to identify what can I do differently the next time I come up with this type of number, because it is a 3-digit times a 2-digit problem. Okay, so what we have here is 3 5/10 times $4.28. So we have this times this. Different ways we can solve this. One way I see kids do this is they decide to decompose the 3 5/10, so that they're doing 428 times 3 and 428 times, it has to be here, 5/10, and then add. That is one way you could solve this problem. And if you choose to do that, which again, your prerogative, you're still going to, at whatever method you use, you're working with these numbers. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8. 3 times 4 is 12. So here I end up with 1248. How do I know it? The decimal goes here. 2 digits behind, because I have 2 digits behind over here. And then you would do the same thing on this end. 8 times 5 is 40. 10 plus 4 is 14. 20 plus 1 is 21. But now I have 3 numbers behind the decimal. So I have to have 3 numbers in my product behind the decimal. And you would then add these up. Stack and add, and you will get your 1498. And this is just a 0, which is the same. Since I'm talking money, I know I don't use that. I would round to the nearest penny, 1498. So that's one way. I don't see a lot of kids doing it, but it is a valid way. Other kids like to use lattice, so just remember that I have a 3-digit times a 2-digit. So you have to have a 3 by 2. And then I'm going to change the color here. And this was faster for some kids because literally they're just multiplying 1 digit by 1 digit. And then they're just adding down. So you're still getting 0, 8, 9, 4, and 1. And then you have to remember again how many numbers are behind the decimal. That's going to be the tricky part. So I have 3 numbers behind the decimal, 1, 2, 3. So I have to have 1, 2, 3. Same thing. 1498. So you could also do that. I get it. A lot of parents don't like this method because it's so different than what you normally do. Sometimes this is where kids are, honestly, and sometimes it's easier for them to do 1 number times 1 number and see everything in front of them than to do traditional multiplication. But since I know that's popular and that's the most compact way to go when you know your multiplication facts, you would just stack it and do it this way. So we already know that 5, we did this multiplication before and we got 2140, so I'm not going to do it again. Placeholder, and we did 3 times 428. So I'm just looking, we already did this math, so I'm just rewriting it here. And so they're getting the same digits and the same rule. I have 1, 2, 3 digits behind, so I need to have 1, 2, 3 digits behind. 1498. Not a hard problem, it's just that multiplication, a 3 by 2 digit multiplication by hand is really tough. And these were decimals, so you had to remember all your math facts, all the times 3 group, and know where to place the decimal when you multiply numbers with decimals. So that was a little bit of a beast. Pick the method that works best for you. That's what matters. Which one works best for you in a way that you can understand and that you can use with the least mistakes on an exam. And then spend the rest of your time practicing to get better. Okay? So let's hit pause and jot this one down into your notes and go to the next section. For 29, our answer is B 7/8. The way I solved this one, I started thinking of how am I adding and what part is missing. So I have 3 things. I have blue, black, and red pens. And for a whole pack, I know I have 4/9 black, 1/6 blue, the rest are red. So just thinking about it very visually. Blue, black, red equals 1 pack. So I know as I'm adding, I have 4/9. Oops, I put that in the wrong row. I have 4/9 over here for black, 1/6 for blue, and I have no idea what the red is. But it would all equal 1. So what I'm going to do, I know I'm adding all these together. I want these denominators to be the same to make it easier for me. And since I have 6 and 9s, I like to go from the lower number and look for a common multiple. So 6, 12, 18, and I already kind of recognize 18 is also a multiple of 9. 9 times 2 is 18. So I'm going to use that and make all my fractions out of 18. Okay, and now since I know that 6 times 3 makes 18, 1 times 3 is 3. 2 times 9 makes 18, so 2 times 4 is 8. And now I just need to figure out what is going to be that last number, because I want to get 18 out of 18. What does that number have to be, that numerator have to be, to make this a true statement? Okay, so now you're thinking, and you're probably going, well, if I add these two together, 3 plus 8 is 11. So how much more do you need to get to 18? And you're probably going, oh, it has to be 7. So your answer is 7 over 18 is red. And that's your choice right there. So this one can look a little tricky when you're adding fractions with unlike denominators when we don't know. We know it's 1 pack, but I'm choosing to represent that 1 as a fraction 18 over 18. And it's always possible that your answer may be in a different form, like it may not be in simplest form, so just be ready for that. All right, hit pause and jot this one down. This one is a tricky type of problem for 5th graders. I've always had kids have a hard time with this type of problem. Another way I have seen some kids think about it is where they're going, well, here I have 4/9, I need to get to 1. And I've seen some kids do this where they go, okay, this got me to 4/9, and then I added 1/6, and they had to change the fractions anyway. So they still ended up having to change the fractions. Oops. Hold on, so this is an 8. And to get to 11 over 18, and then they had to think, how do I get then to this 1 or 18 over 18? And they were like, oh, I have to jump 7/18. So whatever works for you, whichever model or visual, I hope that is super helpful. hit pause and we'll jump to the next section. Here are the answers for 31, D, and C. Check with your work. If you got it, awesome, move forward. If not, stay and watch how we solve this problem. The first one is a volume problem. We want to know how many units are in the rectangular prism. So I'm going to use these 3 dimensions because I know volume is equal to length times width times height. So I can clearly see this is 3 tall, 4 in this one, and here I have 1, 2, 3, 4, 5, 6. So my dimensions are 3 times 4 times 6. The order doesn't matter. 3 times 4 is 12, and 12 times 6 is 72 cubic units. The second one is a division problem. I'm sharing 210 apples into 14 equal groups. So I have 210 divided by 14. Remember, if you don't remember which one goes into the house, you can think of a little kid knocking over the top number into the house, if that helps. All right, and I'll keep using the acronym Dead Monkeys Smell Bad to help us remember the steps. And to make my work easy, I'm going to think of my 14 times tables. 14 plus 14 is 28. Plus 14 is 42. Plus 14 is 56. Plus 14 is 70. Okay, and then I know I have to get to 140. So 70 plus 14 is 84. 70 plus 98 plus 28 is 98. 70 plus 42, so literally in my head I'm just adding 70 to these. And 70, I'm going to end up with a 6, 7 plus 5 is 126. So I have my 14s, and I know I'm going to have 3 digits here. Now I am slowing myself down on purpose because it's super easy to make a mistake here. All right, 2 can't be divided by 14. 14 can go into 21. 21 divided by 14 is 1. Subtract 7, bring it down. And how many 14s can I get from 70? 2, 3, 4, 5. 5 equally. Awesome. 5 times 14 is 70, and I get 0, and there's my answer, 15. Okay, so there you go. You can hit pause and jot this one down in your work, and I hope the division is feeling easier for you. So many kids and adults are scared of division, and it's not that scary. You can just think of small steps to give yourself an advantage and make it easier for yourself. We made it to the end, the very last 3 problems. The answers for multiple choice are A, and D. So mark those down, jot it down. If you got it, awesome. You can stop the video here, and thank you for watching. You can move on to our constructed response video and see how to answer those questions to get full points. If you're still here, we're going to go over these last 3 together. And as always, if you have questions, put them in the comments. If you have other strategies, if you find this helpful, put those things in the comments and share to other people. We'd love to have you here as a subscriber and to have more math marbles on our community channel. Okay, so let's go into the first one, which is a fraction problem. We have Diane, who's walking 3 3/8 miles on Sunday, and she walks 1 5/6 fewer on Sunday, so Saturday and Sunday. So this is going to be a subtraction problem because she walked less miles on Sunday. So different ways I can see this. One, I can just see kids going 3 3/8 minus 1 5/6. I could also see kids modeling and going, okay, if I have 3 3/8, how do I go back 1 5/6? And you can go back 1 to get to 2 3/8, and then now you have to figure out, how do I go back 5/6? That's the tricky part, is our fractions are not the same. So we need to do some fixing before we get to this type of model. So let's pause there for a second and think, what would be a common denominator for 8 and 6. So think in your head, what number can be divided by 8 and 6? If you don't know, you can skip count by 6, 12, 18, 24, 30. I do 5 at a time. 8, 16, 24, 32, 40. And then just look to see where the numbers are the same. And I see over here. So I could make life easier by making these fractions with a 24. And then you're doing your skip counting. How many ways do I skip from 8 to 24? 3 times. So I'll do the same on top. So that's 9 over 24. And 6 times 4 makes 24. So 5 times 4 is 20. So what's the hot spot here? What do you notice about this subtraction problem? What sticks out? Well, I see that I don't have enough to subtract 9 minus 20. I don't have it. So I'm going to have to borrow and add 24 over 24. I have to do that. So I'm going to just erase this line to give myself a little bit of space here. And now I have 33 over 24 minus 20 over 24. That I can subtract. And that will give me 13 over 24. And 2 times minus 1 is 1. So it's a little messy. It's definitely messy. And it might be one I have to recopy over. But now I can do this subtraction to do my fractions and then my subtraction here. But the key was noticing that you could not do this. And so I had to regroup. I had to take one of these and turn it into a fraction. Now, for those kids who were doing it as a number line, you probably wanted to change those numbers first. So if I changed my numbers first and I started with 3 and 9 over 24. And now I can subtract in pieces. So I'm going to subtract 1. So now I'm at 2 and 9 over 24. But I still need to subtract what number? I need to subtract 20 over 24. So I could take 9 over 24 and just get to 2. And then take away another 11. Okay, but again, this is a little tricky, so I'm going to change this to 1 and 24 over 24. And when I take away 11 24ths, I end up with 13 24ths. Not the easiest. You do get the same answer for both. That I'll give you. So just check and think. The biggest hotspots are being able to make these fractions like denominators early before we subtract, and then ask yourself, do you have enough? If you do, just subtract. If you don't, you're gonna have to do some borrowing. All right, so that one was spicy. Take a moment to jot that one down in your notes. Now 34 is a geometry problem. That's really a vocab problem. You have to know what these terms mean. So what is true about a rhombus and a square? So when I think of a rhombus, I know it has 4 equal sides. And it's also a parallelogram, meaning it has 2 sets of parallel lines. So it can look this way with 4 equal sides, or it can be this way with 4 equal sides. That diamond piece, when you think of your tiles, your pattern blocks, it can be that blue pattern block, that's a diamond, or it could be a square. Now when I think of square, you're kind of thinking of the same things. It has 4 equal sides, but and it is still a parallelogram. I still have 2 sets of parallel lines, and the only other thing that's true about it is that it has 4 right angles. So what's true for both are the 4 equal sides and the parallelogram. Okay, so that's what I'm looking for in this answer. And that's where you have here in A. They're both parallelograms and 4 equal sides. I can't say B because sometimes there are times you're going to have a rhombus that does not have 4 equal sides. It can be slanted. And I can't choose C because squares do not have 2 acute angles. And I can't choose D because they have more than one set of parallel lines. All right, let's look at the very last one. And this is another problem where I have to do some unit conversions. It's a measurement one where I have 13 gallons of milk and I need to change that to quarts. So let's do that. We're going to change this to quarts. You can just go into your reference sheet and you'll see that 1 gallon is equal to 4 quarts. So that's there in your reference sheet. So if you have 13 gallons, then you're going to do 4 times 13 to get 52 quarts. If you're somewhere that doesn't have a reference table like at the market, you could just always tell yourself the story of King Gallon. It's not a great story, but it helps me remember, where I know great King Gallon has, and I draw the crown like that, and he has 4 queens. And each queen has 2 princesses. And each princess has 2 kittens. And this is what I use to help me figure out pints, cups, quarts, and gallons, like how many is in each one. So whoops, I forgot one over here. And that's the story. That's how I kind of remember it all the time, and I can really just see that 1 gallon has 4 quarts, or that 1 gallon has 1, 2, 3, 4, 5, 6, 7, 8 pints, or that 1 gallon now has 16 cups. All right, so that's it for this part, Math Marvels. I hope this was super helpful. We've made a ton of videos this weekend, so my voice is pretty tired, but the goal was to make sure that this math made sense to you before you took the state math test. As always, ask questions in the comments, and I hope to see you next time, Math Marvels. Be well.